Hey guys, this is paper 1-2 of the May June 2024 series, and we'll go through each question step by step, so hopefully this video will help you. And without further ado, let's get into it. So question 1. The diagram shows the graph of y equals a sine bx plus c, where a, b, and c are constants. Find the values of a, b, and c. So a is the amplitude, b is the period, and c is whether the graph shifts up or down and by how much. So straight away when you see this graph, you can find the middle part of the graph. So like since you know it's the sine graph, it will look like this. And the middle part of the graph will be this line. To find the amplitude, it's how much the graph goes up from the middle line. So it'll be 1, 2, 3. So the amplitude is 3. To figure out C, you know that initially the graph will be 3 minus 3, and this is the middle line. But since the top of the graph is now at -1, which is this point, the graph has shifted down by 4 points. So it will be -4 because negative means that the graph has shifted down. And B is the period, which is how many sine graphs is within 360. So to figure this out, you can use ratio. So one complete sine graph is within this, which should be 540 degrees. Because this point is -270, and this point is 270. So if we add 270 and 270, you'll get 540. So 540 degrees is one sine graph. So if you want 360, you can use ratio and you should get 2/3. So B will be 2/3. Question 2. Given that this equation, find the value of RS. So this question uses the laws of logarithms. And when you see the logs, they have different bases. So you need to remember that whenever the logs have different bases, you have to change the base to make them the same. So we can change this log with base 9 to base 3. But first of all, we can rewrite it to become s squared. And then now we just change the base. Okay, now we insert this back into the equation. So this part, you can use the laws of logarithms to make both sides of the equation have only one variable. And then rearrange. And RS should be 6561. Question 3. Given that y equals 10x over 2, find the exact value of dy dx when x equals to pi over 3. Okay, so we can rewrite the equation first. And then we differentiate. So the differentiation of tan is secant, so this is why it becomes secant. Okay, now we can change secant squared to 1 over cos squared because of this rule. Okay, so using this rule, we can actually change it to this. And now we just sub pi over 3 back into this equation. And if you plug it into the calculator, you should get 2/3. Okay, so question 4. A team of 8 people is to be formed from 6 teachers, 5 doctors, and 4 police officers. Part A, find the number of teams that can be formed. So this question is about permutations and combination. For permutation, the arrangement matters. And for combination, the arrangement does not matter. And since part A is asking the number of teams, the arrangement does not matter, so it's combination. And firstly, we need to find the total number of people. So we just take 6 plus 5 plus 4. And then we can do 15 C8 because you only want 8 people from these 15. And it should be 6, 4, 3, 5. Part B, find the number of teams that can be formed without any teachers. Okay, so the number of people that are not teachers is 5 and 4. So you just add. And now we know there's 9 possible people that can be in this team of 8 people. So we just do 9C8. Because once again, the arrangement does not matter. Part C. Find the number of teams that can be formed with the same number of doctors as teachers. So for this question, it's easier to draw a simple table. So D stands for doctor, T is teachers, and P is police officers. And then we can have a total column. So we want the same number of doctors and teachers. We can start with 1. So 1 doctor and 1 teacher. Since the team must have 8 people, you need at least 6 police officers, but there's only 4 police officers, so this is not possible. And we can have 2 doctors and 2 teachers. So we will need 4 police officers, which is possible. So this is okay. And then 3 doctors, 3 teachers. That makes 6, and we need 2 police, which is also okay. And then 4 doctors and 4 teachers. And that makes 8, so we don't have any spots left for police. So 8. This is also possible. And then 5 doctors and 5 teachers. This is already over the limit of 8, so it's not possible. And then we can just stop here. And now we just use combination to get the answer. Okay, so there's 5 doctors, 5 C2 times 6 teachers, 6 C2, and 4 police officers, so 4 C4. And you should get 150. 5 doctors, 5 C3 times 6 C3 times 4 C2, 1,200. And last one is 5 C4 times 6 C4. Okay, so the values in front is actually just from the question. Okay, now we have all these. We just add them up. $1,425. So this is the number of teams that can be formed. Question 5. The diagram shows the trapezium ABCD. The lengths of AB, BC, and CD are this and this. The line BC is perpendicular to the lines AB and CD. Part A. Find the perimeter of the trapezium, giving your answer in its simplest form. Okay, so first we should use all the information we have from the question and label in the diagram. Since we want to find the perimeter of this ABCD, we don't have AD, we can use this right angle triangle here. And we know this part is root 7 plus 2. And we can find this length. So we just take 9 root 7 minus 9 minus this part. So root 7 minus 2. So this part is root 7 minus 2. And now we just use Pythagoras theorem to get the hypotenuse. So expand first so that it's easier to see. So the length of AD should be root 22. And now we can just add them all up to get the perimeter. Okay, so this is the final answer and it's in the simplest form. Part B, find the area of the trapezium, giving your answer in this form, where P and Q are rational numbers. So first of all, we need the area of the trapezium. For this, we need the formula. which is a plus b over 2 times height. Okay, so the formula is referring to A, which is this length, and B, which is this length, and then the height is this. So we can just sub them into the equation. Okay, so this is the final answer, and it's also written in this form that the question wants. Part C, find cotangent dBc, giving your answer in this form where R and S are simplified rational numbers. So we can rewrite this as 1 tan dBc. And since if we use Sogatua, tan is opposite over adjacent, and since this is the inverse of tan, we know that is adjacent over opposite. And we can actually draw a right angle triangle using the question. So D, B, C. And this part will be 9 root 7 minus 9. And BC, root 7 plus 2. Okay, so we want the angle DBC, which is this part. And the adjacent is this part, the opposite, and the hypotenuse. And since we have the adjacent and the opposite, we can rewrite this. And now we just rationalize the denominator. Okay, and we can simplify this by taking out a factor. And since the question wants it in this form, we can write it like this. Actually, you can simplify this part even further. Yeah, so this is the final answer. Okay, question 6. The diagram shows a circle with center 0 and radius 5. The points A, B, C, and D lie on the circumference of the circle. The angles are as such. The length of the minor arc DC is 3.75. Okay, so first of all, we can label this diagram first. So the first information is that the radius is 5. So OB is 5 since it's the radius. Then OD 5 and OC is also 5. And then angle TOC equals theta. Okay, it's already labeled. Angle AOD equals angle COD equals 0.5. So AOD is this part. This is 0.5. And angle COB is this part, which is also 0.5. The length of the minor arc DC is 3.75. So DC is this part. And this is the minor arc. And the major arc of DC is actually, wait, I should do in a different color. So this is also DC, but it's the major arc. Okay, but the question wants minor arc DC. So we know that this is 3.75. Okay, so we can use arc length to prove that theta equals to 0.75. And the formula for arc length is r times theta. And since we know the r is 5, and theta we don't know, and arc length is 3.75, then we can just solve for theta. Okay, part B, find the perimeter of the shaded region. So the shaded region is this part, and you want the perimeter of ABCD of this section. So if you think about it, all you need is to find the arc length of BC, and then AD, and CD, but it's this part. And also the length of AB. All you need is these 4 sides. And to find the arc length of BC, you can use this formula again, the arc length formula. Okay, since the question mentions that angle COB and angle AOD is 0.5, and both of these triangles have the sides 5, 5, we can tell that these triangles are equal. So the length of CB should be equal to the length of AD. So we don't need to find the length of AD again. We can find the length of CD now. So to find CD, we can use the triangle DOC, which is this whole part. Since we already have the lengths of both of the sides and the angle, we can use the cosine rule. The theta is from part A. Okay, so this is the length of DC. To find length of AB, we can use the triangle AOB. So let me just draw, since the diagram is kind of messy now. Okay, so this is AB, and this is O. And we can get this angle, because theta is 0.75. So we just add 0.5, 0.5 plus 0.75. And you should be getting 1.75. So this angle is 1.75. And now you can use the cosine rule to find length of AD. Okay, now you have the length of all the four sides, so you can just add them up. So the perimeter is 16.3. Part C, find the area of the shaded region. Okay, so let me just clear everything up. Okay, so you want the area of the same region once again, and you can actually just take the sector AOB minus this triangle and this part, and you can get the area of this. Okay, so first we can find the area of triangle AOB, which we can use the formula half AB sine C. Half AB sine C. So AB is the side and C is the angle. Wait, I think that's 1.75. So the area of triangle AOB is 12.3. Next, we can find this small segment of the circle. So essentially, we can just find the area of this whole sector, and then we find the area of this triangle, and we use the area of the sector minus this part to get the area of this segment. Okay, so to do this, we can use the formula for area of sector, which is half theta r squared. Okay, the angle is 0.75, as we know from the previous part of the question. And the r is 5. So that's why we use these numbers. And now we can find the area of this triangle part. So we can use half AB sine C again. And now we just take the sector minus the triangle. And this is the area of the small segment. Okay, so lastly, we can find the area of the whole sector AOB. And to do this, you can use the sector formula. Half, and the theta is 1.75. R squared is 5 squared. So 175 over 8 is the area of sector AOB. And now we just take this sector minus the triangle, which is AOB, and the segment. And we will be getting 8.72. Okay, so obviously you should, if you want the answer to be as exact as possible, you should use the exact value in the calculator. But if you round it up like slightly, it should still be around the same answer. Question 7. The line y equals 3x minus 2 intersects the curve at the points A and B. The point C with coordinates k 7 over 2 lies on the perpendicular bisector of the line AB. Find the exact value of k. So to find the points AB, we can sub equation y into this equation. And then we solve for x. We can use the quadratic equation. And x can be these values. So a can be 1 over 4 and the y value, we don't know yet. B, 1, y value, we don't know yet. Okay, so we have these 2 points. Now to find the y value, we can just sub the x value back into the y equation. And this is the points for A and B. Okay, so the second part of the question says that C lies on the perpendicular bisector of line AB. Therefore, we need to find the equation of the perpendicular bisector of line AB. And to do this, we can find the gradient of AB first. So using these points that we have just found, the gradient of line AB is 3. So the gradient of the perpendicular bisector should be minus 1 over 3. Because it's always the negative inverse. So now we have the gradient, we can find the midpoint of AB, which will give us a point to work with. And we can just use the midpoint formula. So this is the midpoint coordinate. Okay, now since we have the points and the gradient, we can find the formula for the equation for the perpendicular bisector. and we just find the constant. Okay, last part is we sub the k and 7/8 into this equation to find k. So 7/8 is the y value and k is the x value. So k should be minus 19/8. And this is the exact value. Okay, part B, the point D lies on the perpendicular bisector of AB such that D is a reflection of C in the line AB. Find the coordinates of D. Okay, so this question, you can actually just draw it out so that you can visualize it. So the line AB will look something like this. And since CD is the perpendicular bisector of AB, it will look something like this. And this part is 90 degrees. And since C has to be a reflection of D, let's say C is here and D is here. And then we can just get the coordinates of C from this part A of the question. Minus 19/8, 7/8. And we also need the midpoint of AB, which is here. And this should be the midpoint. And we need to work out how far C is from the midpoint. So 5/8 minus 19/8 minus 19/8, so it becomes plus. And then 3. Minus 1/8 minus 7/8 equals minus 1. Okay, so that means from the midpoint, you need to go left by 3 and up by 1. Okay, therefore to find D, you move rightwards by 3 and down by 1. And we can use the midpoint, which is 5/8 minus 1/8. So 5/8 plus 3 equals 29/8 minus 1/8 plus 1. Wait, minus 1. Minus 1 equals 9/8. And it's minus because you're going down. Okay, so this is the coordinates of D. Question A. A curve has equation this show that the differentiation can be written in this form. Okay, so for this one we can use the quotient rule to separate the top and the bottom. And then you differentiate each part. Okay, so for this equation, we can use the chain rule to differentiate. So we let u equals the inside, and then y equals u to the power of 1/3. And du dx, 6x dy du minus 2/3. Okay, so chain rule is dy du times du dx. So we have dy du, and du dx is 6x. So we just sub u into this 6x, and then simplify. Okay, so we are done with this chain rule. We can continue with the quotient rule, which will be v du dx minus u dv dx over v squared. Okay, so since the question wants the answer in the format with the denominator like this, we have to times the numerator by this part. Okay, so because of that, this part will disappear because you're timesing it, and minus 2/3 plus 2/3 will become 0. So you're just left with 2x times x plus 4. Okay, and the denominator will be the same as the question. Okay, so you can add this too because this part is the same, so you can use the laws of indices to add them up, and they will become 3x squared minus 5. Okay, so this is the final answer. Okay, part B. Hence find the x-coordinates of the stationary points on the curve. Give your answers in their simplest exact form. So for stationary points, the gradient of the tangent will be 0. So that means dy dx will be 0. And you already have dy dx from part A, so you can just equate them to 0. And now you can use the quadratic equation. And if you type it into the calculator, this is the answer you should be getting. Okay, question 9. A particle moves with a speed of 14.5 parallel to the vector. Find the velocity vector of p. Okay, so for this question, you can visualize the vector if you draw it out. So the top part means that it's moving left or right, and minus 20 means that it's moving left by 20, and then up by 21. Okay, so you can use Pythagoras theorem to find the hypotenuse, which is this part. Okay, so the hypotenuse should be 29, and for vector diagrams, whenever you draw the right angle triangle, right, the hypotenuse should always represent the speed. So if this is 29, but the speed of the particle is actually 14.5 from the question, you can divide 29 by 14.5 to find the constant value, which will be 2. So this means that the vector is actually 2 times of the speed, 14.5. So to find the velocity vector of p, you halve the vector like this. And so you can represent it like this. And this is the final answer. So initially, P has position vector 3, 5. Write down the position vector of P at time t. Okay, so you can use the formula R equals A plus TB. R is the position vector, A is the initial position, T is the time, and B is the velocity. Okay, so you have the A and B value. So this is the position vector at time t. The second particle Q has position vector as such at time t. Find in terms of t the distance between P and Q at time t. Simplify your answer. Okay, since we have particle P and Q, and we have the position vector for both of them, we can write different equations. For P, x value 3 minus 10t, and then y value would be 5 plus 10.5t. And then this is P, so Q, x2, y2. Basically, we are splitting the x part and the y part of the position vector. And then now we can use the distance formula, which is y2 minus y1 plus x2 minus x1. Okay, so I'm going to do it separately first and then combine it later. Okay, now we can just combine them. So this is the final answer, and we can just leave it like this. Part D hence show that P and Q never collide. Okay, so for P and Q to collide, the distance between them should be equals to 0. So we can try and equate the equation to 0. And then if you put this into the calculator, you should get an error. So you have to solve it using the quadratic equation. And if you see here, the discriminant is actually negative, which is this part is negative. So you can explain, since the discriminant is minus 1936, there is no real roots. So P and Q never collide. because the distance between them will never be 0. Question 10. The first 3 terms of an arithmetic progression are this. Show that the sum to this arithmetic progression can be written in the form where a is a constant. Okay, so first we can write the sum of arithmetic progression formula, which is this. Okay, so the value of a is given in the question because a is the first value of any progression. And to find d, we can take the second value minus the first value. And this works for the third value minus the second value as well. And now we can just rewrite the equation. Okay, so the question wants it in this formula, so we can rewrite it. Okay, so this is the final answer. Part 2, given that x equals 2 pi over 3, find the exact sum of the first 20 terms. Okay, so that means n equals 20. And we already have x here. We can just use this equation from part 1 and sub everything into it. Okay, and you can simplify this further. So this is the final answer. Part B. The first 3 terms of a geometric progression are this. Find the nth term of this geometric progression. So for geometric progression, the nth term formula is AR power of n minus 1. And as always, a equals to ln to y, as is the first value of the progression. And to find r, which is ratio, we can take the second value divided by the first. And this also works for the third divided by the second. And then we can rewrite this. Then we cancel ln to y, which makes r equals to 2. And then we just rewrite this into the equation, a being ln to y, and then r is 2 and minus 1. So we can leave the nth term like this. Part 2, find the sum to n terms of this geometric progression, giving your answer in its simplest form. So for this question, we'll need the formula for the sum of geometric progression, which will be this. And since we already have the a and r value, we can just put them into the equation. So this is the final answer. Part C. The first three terms of a different geometric progression or distances, find the values of W for which the geometric progression has a sum to infinity. Okay, so for the geometric progression to have a sum to infinity, the ratio has to be more than -1 and less than 1, as you can see here. Okay, so keep this in mind. And the A value is 2W minus 1/4 since it's the first term, and ratio should be 2W minus 1/4 as well. And you can work this out as you take this divided by this. So I'll just show. So this is the expansion of the square. And since it's the same, you can cancel and you will be getting this. So this is the ratio. Okay, so we can use this information to make two different inequalities. 2W minus 1/4, which is the ratio, and this. So these two inequalities. And then we can solve them. So these are the values of W. Okay, question 11, last question. Given that y equals x squared ln x, find dy dx. Okay, so we can use the product rule. Let u equals x squared and let v equals ln x. Then you find the differentiation. Differentiation of ln x will be 1/x. Then product rule is v du dx plus u dy dx. And you just sub everything inside. This is the final answer. Hence find the integration of x ln x dx. Okay, so we can make use of part A. So if you integrate the answer, you should be getting the equation in the question. So we can rewrite this to get this. Okay, so as you can see, I split it. Okay, so as you can see, I split it, these two parts, into different integration. Okay, so as you can see, I split it, this part and this part, into two different integrals. And then we can move this part to the right side. And for this part, we want to make it like the question, right? So we take 2 out. And yeah. And now we can just move 2 to the right as well. So we times everything by a half. 1, yeah. The integration of x, the power, x power 1 plus 1, so 2 divided by 2, constant. X squared over 2 ln x minus x squared over 4 plus c. Okay, so you can also rewrite this like this. And this will be the final answer. Okay, so that's it for this paper. Thank you for watching. If you have any questions, feel free to comment them.